My name is Catherine, and I attended the Geometry of Weavables, Wearables, and Wallpaper. So basically, this lecture covered how ideas regarding geometry of objects is able to be related to things like clothing and like the creation of that, whether it be through fabric or knitting and things like that. She also was able to compare these concepts to other aspects of life, for instance, cacti, crystal and structures, and things like that. And so basically these metaphors like serve as a medium by which we're able to better understand these concepts mathematically and geometrically. I'll be able to talk more about some other applications that I was able to look into of this topic. But first I'm going to give a little bit of a summary of what was talked about and the things that were covered. So the foremost, it's really important to be able to understand symmetry. And one thing that I knew, but I didn't really realize fully until this lecture was all of the different types of symmetry that there are. And so there's obvious types that you learn about, which are translational, which is basically the idea that you have this pattern or small piece of a pattern, and it's just moved around until a pattern is formed. So that's your translational symmetry. But there's also reflectional symmetry, which I think a lot of people are introduced to first, is that reflectional symmetry. And so basically the idea behind reflectional symmetry is if you have one shape and it's reflected, and so therefore you have that reflectional symmetry of those two shapes. And so we see that reflectional symmetry as kind of like as if it we're flipping onto this surface here. And the example that she gave were a lot of flags where you see that mirror symmetry. And this symmetry doesn't have to be just a one-to-one. There could be multiple reflections across different axi. For instance, in the Tennessee flag, we see those three mirrors of symmetry. And so in this topic, we also talk about fundamental domain. So earlier I mentioned how you see that reflectional symmetry if this image is flipped across, reflected across a line, and then that translational symmetry is if you have that piece and it's just kind of moved around. Well, that piece, the original, the smallest form you can get in the pattern that's non-repeating, and that's going to be called your fundamental domain. So your fundamental domain is that part of the pattern that's going to be repeated in some way. Now there's also there's other types of symmetry besides just the translational and reflection or mirror symmetry, and we see that in rotational symmetry. So basically the idea behind rotational symmetry is that you take an object and you're able to rotate it, and then it's still able to stay the same. So I have a little bit of an example. And so let me pull the plastic off of this here, because this can be a type of symmetry that's a little bit harder to grasp. And obviously this is going to be a perfect example because it's imperfect. But if you look at the bottom of the apple, you see these ridges here, and I believe there's 5 of them. And so basically that comes from the rotational symmetry of nature and the flowers and things like that. So the idea behind this is that if I turn so let's say this is my starting point and I turn the apple like that, these ridges kind of like fill in the other place. So you turn it and it looks a little bit the same. So that's going to be your rotational symmetry, and you're going to see that in a lot of things. And so your rotational symmetry is going to be based off of that angular turn. Now, the thing about these types of symmetry is that you can have combinations of these types of symmetry, and so then that can lead to a lot of different combinations when you combine these. And so what we look at is, and as was discussed, was the 17 planar symmetries. And basically these are the 7 different types of classifications of symmetrical patterns that you're going to see, whether it be in fabrics and other objects and things like that. So when we're talking about these types of symmetry, we're able to add an additional concept to this, and that's when it comes to curvature. So we talked about, or she talked about how when you see a clothing object, for instance, the plaid that I have right here, so this is a type of symmetrical pattern. However, if you have that planar pattern and it's in curvature is changed, you're going to see a discrepancy in the pattern. And so our example for this lecture was that of the dress. And so when you have this combination of different types of curvature, which I'll discuss in a little bit, you're going to see those changes in the pattern in certain ways. And then that's how you're able to make this flat piece of material into something with curvature, because people aren't flat, except for flat Stanley, but that's different. Okay, so we see this curvature in the making of clothes. And so when we're making clothes, one thing that I thought was really interesting was when she talked about the pattern for making a dress shirt. So we saw this basically like picture of a shirt, but in reality it's not just two pieces sewn together. There's going to be many pieces to that dress to be able to get that curvature in the way that you want it to be, so that it's able to fit a person, because it's flat pieces sewn together to be able to fit the curvature, like shoulders and things like that. So we talked about Professor Sir Christopher Zeman and his difficulties in making a dress for his wife, but it's just really important to understand how each piece is sewn together. So in this, we're able to talk about how the fabric can be manipulated to form three-dimensional shapes. So this is when we begin to talk about the types of curvature and positive and negative curvature, and how these types of curvature are formed. So foremost, we talked about adding darts, and basically a dart is when you take a flat piece of fabric like this and you kind of pinch an area out. Okay, so when you add that dart, what it's doing is removing area from the piece of fabric. So when you're removing that area, it's going to lead to curvature of the fabric. So how we would determine whether or not that curvature is going to be a positive or negative curvature is when we're looking at when that fabric is removed. So we look at our disclination. So basically what this means is that we take something that has symmetry and we cut out a wedge. So we cut out a wedge of that piece. And so when that piece is put back together, what you're going to end up getting is something like a cone shape when you glue it back together, because that area is removed and then placed back together. So in that, we're going to have a cone point, and that's going to be a positive curvature because it's going to be coming out. However, if we were to take the same piece, cut out a slit, or like a slit in it, and then add that area to it, that's going to create something else, which is going to have negative curvature. And our negative curvature is what we're going to see as the saddle shape, in which there's too much area in the pattern to be able to fit on a flat surface there. So that's when we start seeing the negative curvature. And we're able to demonstrate this using all sorts of patterns, as well as shapes such as pentagons, hexagons, octagons, and all of that. So that's when we begin to see the difference between positive and negative curvature. However, people themselves also have positive and negative curvature. So at my shoulder, we see that I have positive curvature here. But if we were to look at the waist, that's going to be coming in, and so that's going to be that negative curvature. So as a fashion designer, or as a seamstress, their job is to be able to determine where those areas are going to have positive curvature and where those areas are going to have negative curvature, and then how to create this dress that's going to have positive and negative curvature, and allow to be able to make this flat object fit the human body. So we see this joining of the curvatures, in which we are inserting a new row or removing a different row, but depending on where the fabric needs to be added and where it's going to be removed. And so we can also see this in nature, and some of the examples that we were given were crystals and cacti. And so in these concepts, for these structures to be able to grow or shrink, a new row needs to be added. So we see this in knitting a lot, and I'm not sure if y'all knit or anything like that, but I do. And so when you're knitting and you need to make your piece larger, what you're going to do is you're going to add a new column. Actually, you're going to add a new column to each of your rows. And so then what that's going to do is be able to allow you to have that change in the curvature. So when we're looking at the dress, that's actually what we're seeing from when the fabric is removed to when it is added. And so that's what we're going to see in those changes in curvature. And I'll also talk about more about curvature in nature at the end of the video. So we're going to have these disclinations, which are the change in orientations. And so this is a different type of way that we can affect the curvature to be able to fit our needs. And so disclinations are, we can rotate around a point of negative curvature. And so what we're going to be able to see in this is in the sock example. And so, and on your foot you have this heel, right? And so this is going to be an area of positive curvature. So what you're going to do to be able to fit around that is that you have to rotate those rows around that area to be able to get it to fit. And so then that's going to be a type of disclination as well. And so we also see this in the wedding dress ruffles, and basically the concept behind this is that you take a mesh material which is extremely stretchy, you stretch it out all the way, and then sew on a piece of ribbon to that. And so then when it pulls itself back in, you're going to have that negative curvature of the ruffly negative curvature there. And so it's called stretched and sew. So is the method used for that. And so negative curvature isn't just in dresses. We're also going to see it in the mitochondria membrane, as well as in the general universe, if you consider the planes within the time and space there. And so we're also going to see this in a lot of different natural instances, whether it be at the microscopic level or at the visible level. So this is when we come to the Euler's formula. And so Euler's formula is what we're going to be able to use to determine the holes of an object. And so this kind of gets away from curvature just a little bit, but not really, because it's still those geometric principles and those geometric properties. So when we're talking about this formula, basically what we're doing is we are we are determining how many holes and a shape is going to have. And so this is going to be based off of how many vertices, sides, and edges we have to our shape. And so we're able to use this to determine the holes of which determine the holes at which that shape's going to have. And these holes are going to be caused by the interaction of the curvature with each other. So that's basically the major ideas behind the lecture. And so one thing that I would really like to talk about to teach, and as well as to follow up with, is how curvature affects things in nature. So, and how curvature can be changed in nature. So we're going to be seeing a lot of different types of curvature, especially at the microscopic level. And so when we see things like the membranes, for instance, of like the mitochondria, when we see those membranes and those types of and other types of proteins as well, not just membranes, each specific item, I guess you could say, is going to have a specific type of curvature. And so these curvatures are important because it's how we're able to determine their role and what they are able to do, by whether it be by increasing the surface area for cellular functions, or whether it be to fit in a certain way, whether that's in a solution or as a protein, which needs to be in a certain type of shape to be able to be received by a receptor. So in the mitochondrial cell wall, we're going to see that curvature, which plays an important role in allowing for an increase in the surface area within a small area. So I'm going to draw a little diagram here. Okay, so we have this negative curvature here, and so what this allows to do and what it causes is basically this ruffled thing similar to the dress, and so in this regard we basically have too much area for it to fit on a flat surface. So when we have this ruffled area, it's the increase in this, I'm not sure if you can see that, it's the increase in the surface area of the membrane within the mitochondria, which allows for more of the processes that form ATP, and basically just allows for the cell itself to be more productive in that regard. And so we're going to see a lot of this this curvature and this area and this increase in area for a lot of different purposes and things like that. So I hope that covered a lot of things. I tried to explain everything the best that I could. So if you have any questions, comments, or concerns, please feel free to put those in the comments below. And I'm also going to be attaching an additional video, which is going to be talking more about positive and negative curvature, and going to be teaching about that more specifically. Okay, thank you. Bye.